Hi everyone. In this video, I will discuss the solution to the problem reorganize the array. So given an array ARR of size n, indices are from 0 to n minus 1, and your task is to write a program that rearrange the elements of the array such that ARR of I is equal to I if element I is present in the array. And if an element I is not present in the array, then you have to put -1 at the corresponding index. So let's see how we can solve this problem and what is the expected output for this sample test case. So we have to change the value over all the indices from 0 to n minus 1. So for index 0, we do not have 0 in the original array. So we have to change its value to a -1, and since it is already -1, so it will remain unchanged. Then for index 1, we have 1 in the array. So we have to change its value to 1. Then for index 2, we have 2. So change it to 2, its value to 2. Then we have 3. So change its value to 3. Then we have 4, so change its value to 4. And then we do not have 5, so change it to -1. We had 6, so change it to 6. We do not have 7, so change it to -1, and it is already -1. Then we do not have 8, so change it to -1. Then we had 9 in the original array, so change it to 9. So this was the expected output. And how we can solve this problem? So the naive solution is to use an temporary array where you can copy the elements and then update the original array. So that would take order of n time and order of n extra space, since you have to use a temporary array of size n. But here the expected time complexity is linear, which is fine, and the expected space complexity is constant. So we have to reduce the space complexity. Cool. So how we can reduce this thing? So the idea here is to do not use any temporary array and update the values in the original array. So let's see how we can solve this problem in just a constant extra space. So what we can do, for every index I will move its element to its correct place. So what I'm trying to say, so let's say the index value is a 2, so that is ARR of 2 is equal to 6. So at index 2, the value is 6, so that is this element value. This value is not its correct place. So what I will do, I will move this 6 to its correct place. And what is its correct place? That is index 6. So I will move this element 6 to index 6. Very straightforward. So and then I will just simply swap these two values. Swap ARR of 2, the initial value, and ARR of ARR of 2. Or let me write it this way. This is simply equal to ARR of 6. I will swap the values at index 2 and index 6. So these values, so 2 and this one will become 6. And now we have I at ARR of I. So which is an happy case. Then move to the next index. So let me just complete dry run over this sample test case. So here we have starting from index 0, and at 0 we have a -1, and -1, there is no correct place for a -1 because it is out of bound. So I will do not change the value right now. I do not update its value right now. So then what I will do, I will just simply check this thing. If ARR of I, these are the conditions that we have to check for every index I. If ARR of I is not equal to I, because if it is equal to I, then it is an happy case. Move to the next index. We do not have to make any changes here. And then here we have these two conditions to check whether value is out of bound or not. And if that is the case, that is it is greater than or equal to 0 and less than n, then what I will do, I will just swap this value with ARR of I. Cool. That is, I will move element ARR of I to its correct place. And then here I will just simply check if after making the changes ARR of I not equal to I, then I will just simply change its value to -1. That is, we do not have ARR of I here. So let's just completely dry run for this sample input. So starting from index 0, and here its value is -1. So do not make any change. And after this, it will again change to -1. So let it be as it is. Then for index 1, we have -1, and again it is out of bound. So do not make any change. And this if condition will change it to -1, and it is already -1. Then for index 2, I will move this 6 to its correct position and swap these two values. I will just simply swap these two values. So change it to 2 and change it to 6. Swap these two values. And now this condition, error of I is equal to I, that is this condition is false, so while loop will terminate. And this if case is also false, so I do not make any change. I do not change this error of I to -1 because here we have 2. Cool. And then the next element is 1, that is ARR of 3 is equal to 1. So I will move this one to its correct position, that is index 1. So I will swap these two values. So here it is 1 and here it is -1. Cool. And after this -1 is out of bound. So then this if case, and here ARR of I not equal to I. So simply change ARR of I to -1, and it is already -1. Then the next index is 4 and ARR of 4 is 9. So I will move this 9 to its correct position. That is swap these two values. So this is -1, this become -1, and this will become 9. And then here this -1 which is out of bound. So no iteration of this while loop. Then we have this if condition, and here this if condition is true. So change it to -1, and it is already -1. Then ARR of 5 is equal to 3. So move this 3 to its correct position. So that is swap these two values. So this is 3 and this is -1. Then again it is already -1. So do not make any changes. Then index 6. So for index 6, the value is 6. So it is already fixed. It is already an happy case. So this if condition is false, and this while loop will not execute. Then here I am checking for this if condition, and this if condition is also false. So value will remain as it is, and this is something that we want, same as our expected output. And then index 7. So at index 7 we have a -1. So this is out of bound. This -1 is out of bound. So this if condition is false. So while loop will not execute. And then I'm checking for this condition, and here it is true. So I will just simply change ARR of I to -1, and it is already -1. Then what next we have? We have index 8. Cool. So index 8, and so I will move its element, that is 4, to its correct position. So at index 4 we have -1. So change these two values. So change it to 4. That is swap these two values, and this one will become -1. Cool. And then this -1 which is out of bound. So this condition of while loop is false. So do not execute this while loop. Then check for this condition. It is true. So change it to -1, and it is already -1. Cool. Then next index 9, and the value at index 9 is 9. That is ARR of I is equal to I. So this condition is false, and so do not execute this while loop. Then this if condition is also false. So do not change its value. Cool. And now if you see, I have fixed all the indices. I have relaxed all the indices values, that is move all the indices values to its correct position. And if we do not have value I in the original array, then I have updated its value to the -1, same as our expected output. Cool. So this is the complete explanation. And what is the time complexity? So the time complexity in the worst case is 2n, not more than n, and can be considered as order of n. This while loop and will not run more than n time. Then extra space, it is order of 1, since we are updating the original array. So let's just try to submit this problem. So successfully submitted. And one more thing, if in the editor there is a keyword constant in the parameters, then you have to replace this constant. So to solve the problem in constant space. Cool, because you are not allowed to change the constant array. So thank you so much guys for watching the video, and have a good day.